Hi, this is Francis from A+ Tutoring. In this video, I'm going to show you how to use partial fractions to solve integral. Now in this example, I have dx over 2x squared plus 3x plus 1. Two things that come into my mind. First is completing the square. Second is partial fraction. So let's look at how to do completing the square first to see if we should really use completing the square or partial fractions. So I have 2x squared plus 3x plus 1. To do completing the square, I have to factor out the 2 first. X squared plus 3 over 2x plus 1 over 2. Now, this, if I do completing the square, I have x squared plus 3 over 2x plus 3 over 4 square minus 3 over 4 square plus 1/2. Okay, so this is how we do completing the square. If you forget about that, please review your notes on completing the square from high school. Now, from this, I can simplify this into x plus 3 over 4. This is square, subtracting 9 over 16 plus, now a half, I'll put it on 16 as well, which is 8 over 16. Now this will become a minus. So I have 2 times x plus 3 over 4 square minus 1 over 16. Now at this point, I can tell you that I have to use partial fraction. I cannot use completing the square. If it's completing the square, I can use completing the square and replace it with arctangent. The only point is here must be a positive. But in this case, it's a negative. If it's a negative, for sure we need to use partial fraction. If it's a positive, you can just follow your equation here, which is arctangent. Okay. Now, since it's negative, so let me do partial fraction here. So first, I have to make it into 2 factors. So 2x squared plus 3x plus 1, if I factorize this, I'll get 2x plus 1 and x plus 1. Okay, so this is my factors for this trinomial. Now let me rewrite my integral. So I have dx over 2x plus 1 and then x plus 1. Now to write it into partial fraction, I have to make it into a over 2x plus 1 plus b over x plus 1. So this is basically equal to my fraction here, 2x plus 1 and then x plus 1. And then the next step is to basically multiply to have a common denominator, which is the same thing on the right side. So that means I have a times x plus 1 plus b times 2x plus 1. This whole thing is equal to 1, which is this 1 here. Next step is to set, so let x equals to minus 1, so that this whole term is 0. If it's minus 1, I have b, use another color here, so b times minus 1 plus, well, minus 2 plus 1, so it's minus 1. So I have minus b equals to 1. So meaning b is equals to minus 1. Okay, so let x equals to minus 1/2. So the second term here is all 0. Then what I have here is, so minus 1/2 plus 1 will give you 1/2. So I have 1/2 of a equals to 1, meaning a must be equals to 2. So that I have my fraction here, so my integral can be separate into 2 parts now. So let me do that on the next page. So my integral is becoming, my a is basically 2 over 2x plus 1 dx minus, because my b is minus 1, so minus dx over x plus 1. So each integral I have to do it separately. The first one here, so I'll put The first one here, I will put u equals to 2x plus 1, du equals to 2 dx. So du over 2 must be dx. So I have to replace that. How about the next one? Next one, I will set u equals to x plus 1, du equals to dx. So I can just replace that. Now the u is not the same u, okay? So don't mix up the two. You can use another variable if you want. I'm just very used to use u, so that I'm always using u. But keep in mind that this u is not that u. Okay, so this is becoming integral 2 over u du over 2. And the second one here is basically subtract 1 over u du. Now, evaluating this is ln, right? This 2 and this 2 is cancelled, and I have ln of u. Okay, so I have ln of u, absolute value of u, subtract ln of absolute value of u. It's a different u. This is first u, this is second u, right? Plus c. Remember, let me just make sure this is 1 and this is 2, right? So be careful of both of them. So the first one, you have to replace it back with 2x plus 1. And the second one is x plus 1. So let me replace that. So ln of 2x plus 1. And then I have minus ln of x plus 1 plus c. So this is basically my final answer for this question. For more information about partial fractions, please visit my website goforaplus.com.